Chapter 10, Section 1, Probability. The objective is to learn how to find the probability of an event by using the definition of probability. An experiment is an activity in which results are observed. Each observation is called a trial, and each result is called an outcome. The sample space is the set of all possible outcomes of an event. An event is any set of one or more outcomes. This table will help explain some of those terms. An experiment, here are some examples of an experiment: flipping a coin, rolling a number cube or a die, guessing the number of marbles in a jar. Flipping a coin is the experiment. The possible outcomes are heads or tails. That's the sample space. In rolling a number cube, that would be an experiment. The sample space are possible outcomes. When you roll a die, you could get 1, 2, 3, 4, 5, or 6. That's the sample space. In rolling a number cube or a die, an event, the outcome would be 5. The probability of an event is a number from 0 to 0%, 0 or 0% to 1 or 100%. That tells you how likely an event is to happen. Never happens would be 0 or 0%. So let's say today is Tuesday. The probability that tomorrow would be Monday would be 0%. Happens about half the time. Be 1/2, 0.5, or 50%. Notice that the probabilities can be written as a fraction, a decimal, or a percent. Always happens 1 or 100%. If today is Tuesday, the probability that tomorrow would be Wednesday would be 1 or 100%. The probabilities of all outcomes in the sample space add up to 1. The complement of an event is all the outcomes not in the event. The sum of the probabilities of an event and its complement is 1. That will be explained a little bit more down in here. The weather forecast calls for a 40% chance of snow. Give the probability for each outcome. Outcome, you only have two options. One is snow and no snow. The probability of snow, we're going to write that here, and the probability of no snow is going to be written here. Now let's go back up here. I'd like you to write down the probability of snow in this rectangle. And remember, the sum of an event and its complement is 1. That means that the sum of snow and no snow has to equal 1, because those are the only possible outcomes. So please fill these in. Example 2. Give the probability for each outcome. Here's a spinner, and we have an arrow that we're going to spin around on this spinner, and it's going to land in one of these areas. The possible outcomes are the striped area right here, and that matches with these two. The area that has dots, those are the bottom ones right here. And the checkered pattern, which is over here. The first one, if I spun this spinner, what's the probability that the outcome will land on the stripes? We're going to write that as a fraction. Be 2 out of 6. I'd like you to please calculate the probability that this spinner would land on one of the areas that has dots. Write that here. And then one of the areas that has the squares. Please write that here. And remember that all of these three added together have to equal 1, because these are the only 3 possible outcomes. Example 3. A bowling game consists of rolling a ball and knocking up to 5 pins down. The number of pins knocked down are then counted. The table below gives the probability of each outcome. So the number of pins knocked down, 0, 1, 2, 3, 4, or 5 pins could be knocked down. The probability that you will not knock down any pins would be 0.175. The probability of 2 pins is 0.264, etc. Letter A. What is the probability of knocking down all 5 pins? Please write your answer here. Letter B. What is the probability of knocking down 3 or more pins? Now that's written as a capital P and in parentheses 3 or more. And this would be read as probability of 3 or more. Up here this would be read as probability of 5. Probability of 3 or more pins. Take a look at the table in which of these outcomes would satisfy 3 or more. You're going to add those together. So it would start off with 0.205, and you need to add this probability and this probability. Please write the sum as a decimal and then as a percent. In letter C, what is the probability of knocking down at most 2 pins? Now let's go back to the table and figure out which of these satisfy that. At the most 2 pins. We're going to start off with the most being 2. This does satisfy that condition, 0.264. However, so does this, and so does 0 pins. So we're going to calculate the sum of that, write that as a decimal and a percent. Please do that. Now, if you recall from the previous slide, it was talking about a complement. What they mentioned was this: the sum of the probability of an event and its complement equals 1. So you already answered letter C. However, I'm going to explain how to answer that in a different way. Over here, it says the event and its complement equals 1. So what we could do is start off with 1 and subtract the complement to calculate the event. Start off with 1, subtract the complement, and we would end up with the event. The event, in this case, is calculated already up here, and that is knocking down at most 2 pins. That came from the sum of these 3 probabilities that satisfied this condition, the probability of knocking down at most 2 pins. The complement of this event is everything else, which would be 3 pins, 4 pins, and 5 pins. Now, if you look up here, everything is highlighted, which means all possible outcomes are highlighted. Together, the blue and the yellow have to equal 1. So, what we could do, that complement is already calculated right here. You calculated 3, 4, and 5 pins together. We can start off with 1. We can subtract the complement. And by doing that, we can calculate the event. So please copy this down and fill in the blanks.